Well, welcome to this latest update on nowRail, and I'm going to be looking today at controlling servos using the PCA9685 servo driver boards. And this video has come about because of the users who are now sort of testing out nowRail. This is a suggestion for a modification to the way the servos work, and someone suggested that we allow speed control on servos. So let's have a look at how this looks in reality. So as you can see, I've got 4 servos, and any moment now they're going to move. As you can see, this one moved very quickly and these ones moved progressively slower. Now this servo actually took 6 seconds. I think this one's 3 seconds, 2 seconds, and this one is set to move as quickly as possible. So let's just watch that again and you'll notice again the speed differences. So as you can see, this update now allows us not only to set the angle of the servo, but the speed that it takes to move between the 2 points. So let's start by looking at how this is done. Now, as always, if you go to the nowRail page on the Digital Town website, you will find all the details. So let's start there. So here we are on the nowRail page, and all you need to do is scroll down to PCA9685 servos, click on the link, and you will find first of all the circuit diagram. Now quickly going back to the breadboard, these are the boards that we're talking about. These are a PCA9685 servo driver board, and on these various ports you can plug in a total of 16 servos. Now there are some little tabs here. None of these have been touched. This little tab has been soldered over. Now by doing that you can change the address of the board, so you can daisy chain these boards, and I think in total if you set all the addresses differently you can have something like 900 servos running off all of these boards. nowRail will actually support that if it needs to. The servos I tend to use are these MG90s. There is an SG90 that you see a lot in the Arduino starter kits. It's a blue version. The only difference really is this one has metal gears, the SG90 has plastic gears. One thing to be aware of though about this, I've got 4 servos plugged in. I'll be honest, I did have 5 servos plugged in, but I had some problems, and that is because of power consumption. Now, unfortunately, my workbench only has a very low power supply going to this particular board, but these servos can pull up to 400 milliamps when they're, if you like, pushing a heavy load. Maybe it's sort of got to the end of its movement and it's trying to go that little bit further. So if you're moving lots of servos simultaneously, then you need to think about the power supply for your servos. Right, let's get back to the circuit diagram. So looking at this diagram, let's just try and zoom in just a little bit. There we go, that's a bit better. The way I run this on my layout, I have a 5-volt supply coming. That 5 volts goes to the VIN pin on my ESP32, and obviously the ground is connected. Obviously on my breadboard I'm using the USB power, but I don't do that on the layout itself. Now the PCA9685 board needs to power the servos, and the servos require 5 volts. So when you look on these boards you have a number of pins, and the first pin right on the very end here is the V plus pin. Now this is the power supply for the servos, and when you look at the boards, this is actually the red pin that goes up the center of the board. You then have a set of ground pins and then the yellow pins are the signal pins. So this 5 volts has got nothing to do with the control of the board. It is the power supply for the servos, whereas I then have a connection here from the 3 volts or 3.3 volts of the ESP32 that comes to the VCC pin, and this provides 3.3 volts for, if you like, the logic of the circuit. Now this is important because the ESP32 is a 3.3 volt board. If you put 5 volts in the VCC, it means that your SDA and SCL connections, the one that, if you like, is feeding back to your ESP32, is going to be sending 5 volts to your ESP32, which is going to have a really bad day. You're going to let the smoke out. So that's why we need a 3.3 volt for the logic, so that, if you like, the communication is via 3.3 volts, but we have a separate 5 volts that is the power supply for powering, if you like, the motor side, whereas the yellow, the digital signals, will be coming out at 3.3 volts, but that's fine for the servos. The 5 volts does, if you like, the motor in the servo. The 3.3 volts is just saying this is how far I need you to move. Now, one other thing, obviously, make sure all your grounds are connected. Now, there are 2 ways if you're using a lot of servos, and on my layout, I'll be honest, I use these for not only the servos, I use them for my LEDs as well. There is a separate section on the nowRail site about how to use that. Now you can, if you like, put your connections in here and daisy chain them out of the end, or the way I do them on my layout is I've got these boards sort of side by side and these pins are all just connected up in a row. It's up to you how you connect those up, but that is the basic circuit, and you can put, if you like, a number of these boards in if you need a large number of servos. Again, the warning, make sure you've got enough power supply going into the 5 volts, because you'll soon start chewing through some amps if you're moving lots of servos simultaneously. Obviously, if you're moving them one at a time, you're going to not use as much power. Now, one last thing about the connections, we have a SCL and an SDA connection. Now, if we are using the ESP32 dev module, which I'm using here, that is pins 21 and 22. However, if we're using a ESP-8266, you can see that the SCL and SDA are different. Now, you don't have to set the pins in any setup. That will automatically be taken care of by the wire library. However, you do need to be aware, if you like, which pins you're going to be plugging into, so make sure you know which board you're using. I'll be honest, I use these ESP32 Vroom 32s in just about everything, as they just suit my needs. So that's the one I should be using for this demonstration. Now, if you want more information on the PCA9685 boards, if you go to the components section of the Digital Town website, there is some more information just specifically on using these boards and how to change the address, etc. Right, let's work out now how we set up the servos to move in nowRail. So here we are with a brand new version, a nowRail version 1.1.0. and I'm going to show you now how I would build this project. Now, the first thing is save as, and I'm going to save this one as servo test. And then what I tend to do, once I have done that, coming back to the setup, I will change the name here. I tend to do that just so that I can keep track. It means that when the board starts, or if I look on the board in 3 months' time, I know which sketch is actually running on the board. I've just got to check the serial monitor. Now, as always, I'm going to use the default address. You can set up your own unique layout address if you are building what I would call an exhibition layout. Using the default address is fine if your layout's at home, you know, it's a static layout. If you are going to an exhibition, it's good if you put a custom address in, because otherwise if someone else is using nowRail and you've both got the same address, you're going to finish up controlling each other's layouts. Just a bit of a warning on that one. Right, so once we've done that, the first thing you need to do is go to the nowRail user setup. And in this section, you just need to uncomment the wire library and then come down to this section on the servos. Now, there are 3 lines that need to be uncommented. Now, going back to the Digital Town website, if you can't keep up with the video, it's all listed exactly how this is done, so don't panic. The way this works, there are 2 values here, servo min and servo max. Now, this has got to do with the way that servos actually work. If you understand and really want to fine-tune your servos and understand them, then feel free to edit these values. However, these values work with every servo that I've tried them with, and you know, especially the MG90, SG90, the little servos I've got on my desk at the moment, which are a different type again. So unless you really feel the need to fiddle, leave those values alone. The other value is this one here, the max PCA9685 servo boards. Now, the default value in nowRail is 5. That means you can have a maximum of 5 boards connected to your ESP32. If you're only going to connect 1 board, then feel free to lower the value. The reason I set it as a default for 5 is on my layout, I will have 1 board that is controlling servos. I've then got usually 4 more boards per layout board that will be controlling LEDs. So in total I need 5. So I've just left that in as the default. That's all you need to do in the nowRail user setup. Next thing, you just go back to the main page. Now, scrolling down the Digital Town website, we actually come to the function that we are going to use, and it is this add PCA9685 servo. Now, there is the older pre-version 1.10 version. The only difference between the new version and the old version is 1 more variable has been added, and that is the move time. Now, the move time is the total time that you want the servo to take to move from the first angle to the second angle. Now, this doesn't matter if it is only 3 or 4 degrees or whether you want it to move a full 180. The time is the time that you want it to take to move that distance. nowRail will sit there and work out the, if you like, the timings per degree to get that movement. So this is the function. Let's just copy that and put it into our code. Again, there is an explanation, if you like, bit by bit of what all these variables mean. So again, if you can't keep up in the video, please just feel free to come back to this. And again, there are some samples on how this actually works. So I've pasted in the function straight out of the website. Let's just comment that out so we don't crash anything. It's useful to have this here as a reference. Now, to actually use it, we have to put the prefix in front, the myLayout dot. Now, if you're wondering why that needs to be done, that's because I have set up nowRail with an object called myLayout. If you're not an expert in this sort of thing, don't worry about it. Just leave the default name in and you will be fine. So now we have the function, and I'm going to put in some values so that we can actually make something work. Now the first thing that needs to go in is the board address. Now the default address for these PCA9685 boards is 0x40, hexadecimal value 40. Now if you change, if you like, you solder over those tabs, then the address of the board will change. To find the address of the board if you've changed it, go into your Arduino IDE, go to examples, go down to the wire library, sorry about the number of libraries I've got loaded, load up this sketch called wire scan. Just run the sketch on your board, check on the serial monitor, and it will actually show you the name of the board. But we can just do that just to show you it in action. So it's scanning away, and as you can see, it's found an address of 0x40 and 0x70. Now you can ignore the 70, you'll quite often get this, it's sort of an all ports broadcast, I think, but 40 is the one that I am interested in. So coming back, we now have the port. Now you could have multiple servo boards. If you need more than 16 servos, then obviously you may find that you're writing lots of different addresses in here. We then have the port. Now the way the ports work, if we go back to the camera, the ports start, if we look at, if you like, the pins where we connect the board up, 0 is nearest to the pins, and you work up to port 15. So it's 16 ports, but they are numbered port 0 to port 16. Now on my test setup on the test bench, I have got ports 12 to 15 in action. That's because they're at the top end of the board and were easiest to get to. So let's set this first one up. So it's in port 12, and I am going to give it an accessory number of 2006. Now, one thing to be aware of, if you are driving nowRail from your DCC command station, then keep the values below 2000. Most DCC control systems will only, if you like, control accessory numbers up to about 2000. Some of them it's just over 2000. Because I'm not using my DCC controller to drive the accessories, mine are completely driven by nowRail, I can use any value I want. So I've used 2006 for this particular example. Now I'm going to start with an angle of 50 degrees. I'm then going to make the opposite, if you like, the way that it's going to move. Notice this is angle 0 and angle 1. So with your, if you think of a DCC controller, when it sends out a command packet, it sends out a value of 0 or 1. If you send out a 0, the turnout moves in one direction. Send out a 1, it goes in the other direction. So sending the 0 is going to set it to an angle of 50. Sending the 1 is going to send it to 150. Obviously, if you want it to be the other way around, please feel free to swap the values around. Then we've got the move time. Now for this example, I'm going to set it at 6000. So that is 6 seconds, 6000 milliseconds. Now that is quite a long period of time, and probably much longer than you would want. I reckon looking at videos of turnouts moving on real railways, I noticed when I was watching a manual signal box, the turnout seemed to move in about 1 to 1.5 seconds, whereas a electronic movement one of these ones with the big motors on a main line, that actually took about 2.5 seconds. I think it was because it was a much longer turnout and it had a number of motors on it, so probably heavier, and they didn't want to bend it. Anyway, we've got 4 servos, so I'm going to copy this down. Mine are all on board 40. If I had one set to board 42, that is all you would do is change that address in there. I'm now in port 13, 14 and 15. I'm going to use accessory numbers 2007, 2008 and 2009. And we're going to set up, I'll leave the second one moving the same angle, I'll do the third one the same, and the other one we'll make it go the other way. You know, we're going to put in 140 and 30 just for a change. I'm going to set the speed of the second one to 3 seconds. The next one I'm going to set to 2 seconds. And finally, I'm going to set this last one to 0. Now, the way this system works, you have to be realistic. Even when a servo moves as fast as possible, it still probably takes a quarter of a second to get somewhere. So if you set the value at 250, it's probably going to take the same time to get to its destination as if you left it as 0. So the higher the value, the slower the servo will move, but obviously the servo can only move literally as fast as its mechanics can move. And if you want it to move as quickly as possible and be absolutely sure of that, just put a 0 in, and that is it. So that is the code. That is all you need to do to add those 4 servos with their movement. So I've uploaded the code, and if we go to the webcam, the servos are sitting there doing absolutely nothing. And the reason for that is quite simple. Going back to our code, although the servos have been set up, they are obviously waiting for an instruction. So I just need to send these instructions over. Now, the way I'm going to test that everything is working is I'm going to use a custom function. I could have just set up another ESP32 with a button on it to do this, but or I could have used my layout controller, but I'll be honest, it's freezing in my garage today. It snowed, so I'm not going out there. So I'm going to use a custom function. So I'm going to use it based on time. So I'm going to uncomment this current millis and my time events. I've got time millis and time timer, and then all I'm going to do is go to custom functions, scroll down to where are we? Where's my time events? There we go, my time events. Now this is basically a timer system, and yeah, there's just a counter running, and I'm just going to set up some commands here. Now you'll notice that there are some, if you like, samples in here. Let's just uncomment this. Now we are using, if we go back to our setup, we are using 2006 to 2009. You can see there are some values here from when I was testing, and there's 2005. I was running 5 servos. The reason I'm running 4 is I ran out of power. Now, thanks to one of my testers, Paul Raggett, who's done a great job on testing. He's put 16 servos on and tested them, and again, everything works fine until you run out of power. So the way this is working, it's going, once we get to 15 seconds past the minute, it will send an instruction to drive these servos in one direction, and when it gets to 45 seconds past the minute, it will send these in the other direction. it's quite a useful little function if you just want to test something without needing to add extra sort of buttons or extra sort of boards. So let's just get this uploaded. So I've uploaded the code. As you can see, the timer is running down. When we get to 15 seconds, all the servos move to their position. You'll notice they jumped right at the beginning. That's because they were going to a start position. Once they've, if you like, found their start position, they'll just move normally, and you'll see this as the counter gets to 45. He says, waiting patiently. Here we go. So at that point, we can see all of our servos are moving correctly. Now, obviously for this test, I am moving all the servos together. The reason for that is when you're testing a system, you want to, if you like, test it under the maximum stress possible. Obviously it's fine when you just test it, you know, one servo at a time, but it's quite useful if you can see, are there any problems when everything's running? And as you can see, nowRail is handling these 4 servos, and we know from testing that it handles as many servos basically as you put on the system. So that's the end of today's update. nowRail now has slow motion servo control if you need it, and for those who don't, you can just continue moving the servos as quickly as possible. Hope that's been useful for you, and thanks for all the feedback from those of you who've got in touch that are using nowRail, and thanks for the suggestions. Obviously this was a user suggestion, it's not something that I use on my layout, but someone else suggested it and it was a good suggestion. So we are updating things as people have various ideas. Anyway, thanks for watching, and I'll see you in the next video. Bye for now.